Okay, welcome everyone. My name is Maximilian. I'm working for EclipseSource, and I would like to talk to you about JSON Forms 2.0. Before we dive into the slides, who of you has heard a presentation of me or one of my colleagues on JSON Forms 1.0? Very few. That's good. So I'll be a little bit more detailed on what JSON Forms actually is. Is anyone here who's already using JSON Forms? Show of hands, who's using JSON Forms already? Okay, good. Let's change that. So the problem that JSON Forms is trying to address is that in many applications you have forms, like the form that I'm displaying here. If we have a look at that form, there is different input fields for different values. Those values have different types, and you need a widget that represents that type correctly. And those forms are usually dispersed in your application. We are talking about web applications here. So in your web application, at different locations, you will have that form. At other places, you will have something totally different. JSON Forms will allow you to write a regular application, like you would do it anyway, but only in the places where you would have forms, you can use JSON Forms to define that forms. And this has several advantages that I will come to later. Now, if we look at that problem a little bit more detailed, usually you have some kind of data model and you will display something from that data model in a particular form. So in the example here, I have a class task, and this has a number of properties like a name, description, due date, and done. Those properties are typed usually, so we can see that name and description are strings, due date is a date, and done is a Boolean. Those classes could be nested as well, so they could contain other entities in an array maybe. And the purpose of JSON Forms now is to somehow help us to map that on a form-based UI. And that doesn't necessarily mean you do that in the same order. Also, you might want to have some kind of layout. Some things are displayed maybe without a label. But in general, every one of those attributes is mapped into one input field that shows the value of that property. Now, in JSON Forms, we somehow need to know what your data model is. And for that, we use a declarative data definition. And the format that we use there is a standard that is called JSON Schema. JSON Schema basically is what XML schema is for XML, just that it is for JSON. So it describes your JSON-based data. It is very much focused on data validation, so it has a lot of options to also not only describe that your name is maybe a string, but that it's a string with a min length of this, a max length of that, maybe even a string that follows a certain regular expression. This JSON schemata are just regular JSON documents, so they can be created manually. They can also be generated from other data definition formats. So maybe if you already use EMF, you can generate those JSON schemata from an EMF eCore. And if you have an XSD, you can get an eCore from that and then generate a JSON schema. So for many of the customers that we have, when they use JSON schemata, they don't actually write them by hand. They generate them from another artifact that they have that describes their data. On the right-hand side, you can already see a preview of how that will look like. Just as a small example, so here it says that we have a property with the name, with a type string, and with a minimum length of 1. That is a JSON schema describing one attribute. Now, a second thing that we use in JSON Forms is a declarative UI definition. We call that a UI schema. And the idea of that is you don't only need to know what your data is and what properties you have in your data, you also need to know how these are layouted into a form. It's, again, a declarative format. It describes the layout. It describes also the data binding. I will detail that in the following. So it describes how a particular input field binds to something from the data model. It does not describe the data again, so it's a separate artifact. So you have a JSON schema and you have a UI schema, and the UI schema references the JSON schema to say which data is being displayed. Now, how do we combine that in JSON forms? Let's look at more details. So basically, we take a JSON schema that describes your data. So for instance, it could describe one task or one user class. And then we add something that we call a UI schema that describes how that data maps into a form. And then we get a user interface from that, not the full user interface, but a form that you can embed into your user interface at a point of your choosing. And this form is created by something that we call a renderer set. So a renderer set is something that takes a JSON schema and a UI schema and renders a form for you at runtime. This term of a renderer set is important because I will use it often in the presentation. So you can imagine that when JSON Forms renders something, it always needs a renderer set that produces the form. If we look at that, not from a conceptual perspective, but actually how that looks like, it's basically two JSON files that you need there. One JSON file that makes up your schema and one JSON file that makes up your UI schema. And this is the basic parameters also that you need to pass into JSON Forms to get a form. Now there is two concepts that are important to understand how JSON Forms work. And the first one is, how do we render controls? So a control is something like that, usually a label and then an input field. Sometimes it doesn't show a label for something. And the input field does not necessarily have to be a text input, of course. It can be a drop-down. If it's an enum value, could be a date picker or something like that. So if JSON Forms finds something like that, it will be responsible, the renderer set will be responsible for producing what we can see on the right-hand side. So it needs to produce a label with this respective input field in HTML. When I say that the renderer set needs to be responsible to do that, it's actually a renderer. So that's why it's a renderer set. It's a set of renderers, and each renderer is responsible for a particular type of input field. So there's a text renderer, and this text renderer is responsible for creating text input fields. Of course, it's not enough to only display that stuff, because we can see that in this input field there's a value already, prepare slides for demo. So where does that value come from? The value comes from a JSON schema. It comes from a JSON object, and that's described by a JSON schema. So we can see here that the control will have to data bind against a property from the JSON schema. In this example, it's the name property. How does that look like in code? So if we look at the actual artifacts that would underlie this example, here we have a control. So it's just a JSON block that describes this is type control. And then we can see, and this is responsible for rendering this. And then we have a data binding onto name. So in the schema, this is what describes the name property. So we have a type string with a minimum length of 1, and the property is called name. And this part here is the actual data binding, the yellow part. So this tells JSON Forms that this control will bind to the name property from the JSON schema. This can be also a path that is nested deeper, so you can also bind to something that's maybe in an array or in an object property and then again another property, but this is the simplest case of binding that. Then the second concept that we need to understand, the second and last important concept, is layouts. So far you only get controls, but no one really told us where to put those controls, right? So we need to define an order for that controls. We need to define, in the example that we have here, the due date is on the left-hand side of rating, and so on. And that is done with layouts. So there will be a layout, in this case a vertical layout, that tells us that we basically have two lines. And the second line will be a horizontal layout, which also has two columns. And this is how we come to that particular layout, which is a simple example. If we look at that in code, now we're only concerned with the UI schema, because that doesn't really, the layout doesn't have anything to do with the actual data. So it's just UI schema information. And if we look at that, we can see that the outer element is a vertical layout. So that's responsible for having two rows. Then we have the two rows. The first row is just a plain control. And the second row is again a layout, in this case a horizontal layout. This is now responsible for having two columns in this case, because there's two children. So the horizontal layout has a control again and another control. And this is how we come up with that quite simple layout. There's other layout elements than horizontal and vertical layouts, even some more complicated ones like a tree. But this is the basic idea. So the layouts are responsible for producing how the controls are actually fit onto the user interface. Okay, so let's dive into a demo now. I want to show you how that actually works in practice. What I have here is a seed application. I have downloaded that seed application just from GitHub. So if you go to JSON Forms, there is a couple of seeds. One of them is a seed for a React application. So it's a minimal React application that embeds JSON Forms, and it's quite good to get started and to get an overview of how you can work with that. If we look at that application, there's an index.js, obviously. In that index.js, you will see that later when I started, we define some data. That's usually the first parameter that you pass into JSON Forms. You have one object that you want to display in that form. And then we create a store. So we're using Redux here. If you're familiar with that, you work with an immutable store. And then what we put into the store here is the data, the schema, and the UI schema. And that's usually the triple that you pass into JSON Forms. You need to have some data so that JSON Forms knows what to display. If something is changed in the form, it will be directly changed in that object that you passed in. So if you pass in an object and later on you take it away again for submission, for example, this object will reflect the latest state of the form. So this object is data bound to the form. The second parameter that you usually pass in is a schema that describes the data that you have, so that JSON Forms know what kind of data you are displaying there. And finally, you can pass in a UI schema that describes how the form should look like. I'm saying can because you don't have to. If you don't pass in a UI schema, JSON Forms will just generate one for you. Basically, it will take every property and just display it in one column. So if you just get started, that is maybe useful in the beginning. Later on, people usually customize it by using a UI schema. Then when we look at the actual React app, this is the actual React app. It has a header with some logo. The interesting part comes down here. So we will have some text above the form, rendered form, and then we have a JSON Forms tag. And this is the tag that is actually responsible for telling the framework that at this particular location you want to have the form. And it's the form, this form tag will pick up what you put into the store previously. So into the store that surrounds the app here, or you could do that deeper nested in the application. Then of course, we also have the schema itself. This is the schema itself that we're using. So it's the schema from the slides. It's a name property, description property, done, due date. So it's modeling a task. And we also have a UI schema. It's also the one from the slides. So we have a vertical layout and so on. But let's just look at how that actually looks like in a rendered result. So I'm going to fire up that seed, npm start. So this will now compile, start a server, and then serve me that application. In this demo application, this is the header we saw in the data. On the left-hand side, this is just for visualization. This is the actual data that was bound to the form. So those are also the values that we saw are initialized by the application. And on the right-hand form, we have this text we talked about, rendered form, and below that, we have the actual form. And everything in this area here, this is what is rendered instead of the tag JSON Forms by the JSON Forms framework. Everything else is just your regular application. This form is fully functional, so if I click here, you can see that the value will toggle on the right-hand side, and you can also enter stuff here. We have seen that I think there is a date picker as well. You can change values here. So it's just a form as you would probably expect that it actually works. You can also see that there's some validation constraints already running in here, so the rating can supposedly not be higher than 6. That's something that's also coded in the schema, but we will come to that. We will come to that now. Validation. So you might think that maybe just writing such a simple form is really a piece of cake, and there's some truth to that, but things get more complicated the more features you add, and usually there is more features in the form than just displaying the fields. And the first feature I would like to talk about is validation. Since we have a JSON schema that describes our JSON, we use that for validation. And since it is geared towards validation, there's really a lot of options that you can put into a JSON schema to say when your data is actually valid. What I'm going to demonstrate is just 2 simple options. The first one is the name property. I could limit that to a min length. And the rating property I have actually already limited to the maximum of 5. This is why I get this validation error. So in the background, when something changes in the form, EMF will trigger a JSON schema validator. It's using a validator that's called AJV for that, but there's a bunch of validators for that, for JSON schemata. And this validator will throw an error for this particular property, and then JSON Forms will map that back onto the form and display it to the users. So let's look into our schema again. So we can see that this rating thing we've already encountered. This is here. There's a maximum value for that. For the name, there's nothing set yet. So I'm going to add something. I'm going to add a min length restriction with a value of 3. And furthermore, I'm going to add a max length restriction with a value of 10. If I save that, go back to my application, I can already see that it is active, because now it reminds me that even the initial value is incorrect. If I shorten that, I'm fine again. If I have less than 3, I get this validation error again. This is actually something you could even change at runtime if you wanted to, the schema. Then a second feature that is quite frequent, if you have some part of the form that is not supposed to be filled in any case, that maybe depends on the value of another input field, you could, with JSON Forms, either disable or hide that entire section of a form. In this simple example, we are going to look at the value recurrence in a task. If recurrence is set to never, it doesn't really make sense to enter a recurrence interval. If recurrence is set to something different than never, like for example daily, it makes sense to maybe fill in something into the recurrence interval. If you want to implement something like that, you can use visibility rules for JSON Forms. In the example that we have there, if we look into, so visibility rules are part of the UI schema, and they are attached to the element that is to be hidden, disabled, shown, or enabled. And in our case, it is a control. It's this control here that binds to the recurrence interval, and it has a rule attached. A rule has an effect. In our case, it will hide. So it will hide when the condition becomes true, and the condition again binds to a property, the recurrence property. And the expected value is never. So when in the recurrence interval the expected value becomes true, which is never, then this entire control will be hidden. So let's look at how that executes, because it's already in the schema. Now the current value is daily. If you change the current value to never, you just don't have that input field. And if you change it to any other value, it will show again. You can attach those rules not only to controls, but to entire layouts. So you could also hide an entire group or section or tab of a input form. Then something very important, custom renderers. Actually, I could scratch custom, it's just renderers. Everything that we've seen so far, the controls that allow you to input something, this is created by one class, a renderer. So there's a renderer for creating text input fields with their labels. There's a renderer for creating a Boolean control where you have this checkbox. There's a renderer for a dropdown and so on. And even in the core framework, those renderers are the same renderers that you could also add to the framework. So they are registered using the same mechanism that I'm going to show in a second. And a use case for those renderers is if you would like to change how something is rendered. Let's look at the rating, for example. The rating is something that is now limited to a maximum of 5. Maybe I should also input a limit of a minimum value of 1. Then I would have a 1 to 5 star rating. And maybe an input field with an integer is not the ideal way to do it. Maybe something like that would be better in an actual UI. So you can just drag the amount of stars and thereby you input a value for rating. And this is something that can easily be done with a custom renderer. So if we go back to the index.js, this is where we set up all the available renderers, and this is also where we can register an additional renderer. I've already prepared that. So here I will register an additional renderer called rating control with rating control tester. So what's this tester? Let's just look into the code of that. The tester is responsible of telling the framework when this particular control is actually meant to become active. And there's a number of convenience methods here to be able to create a priority for a renderer, but in the end, every renderer will be asked if it would like to render a particular element from the UI schema, like for example, the rating control. And then it can respond with a priority, and if that priority is the highest priority among all the existing renderers, it will become the control to be rendered. And this basically says, I will rank with the maximum number, so I will take priority over everyone else if the scope of this particular control ends with rating. So this is an example where you bind to one particular value that is displayed in the UI. Other examples is you would say that you want to render for everything where the type in the schema is maybe a string, because you just want to have a different control for a string. So in effect, you can override any of the controls and their renderers that are active in the core with your own, or you can just plug in a couple of them for dedicated use cases. Once I've activated that, I didn't look at the control yet. So this is the actual control. A control usually only needs to create a small HTML snippet, a template, that is then put in the place where the control is. We are using a rating component here. The rating component will require a value. That's the initial value it will display. This is something you can just get ejected via dependency injection. And furthermore, it needs to react when there is a click event, and then it can again get injected a handler method there to pass on the new value that was selected to the framework. And that's already everything that actually makes up this renderer. If we now switch back, we can see that the form was re-rendered and we have the rating control here. And when I select something, you can see the rating value on the right-hand side change. So now you have created a custom control that's only responsible for rendering a rating input field. I have talked a little bit, actually not that much, about EMF forms. If you are using EMF, there's also a framework that does basically the same thing. So that allows you to create form-based UIs displaying entities, Java, POJOs that have been generated with the Eclipse modeling framework in a form-based UI. It works the same way. You take an eCore, which is the equivalent to a JSON schema, a view model, which is the equivalent to a UI schema, and it will generate your user interface, for example, in SWT. There's some other flavors there as well for JavaFX, for example. And the idea or the integration that we have will just export an eCore to a JSON schema, a view model to a UI schema, and by that you can convert your desktop-based forms into web-based forms. I have a modeling edition of Eclipse here, and EMF Forms ships with that, so I can demo that quite easily when I just use the examples that ship with EMF Forms. And in the examples, there is a view model. So I will just install that into my workspace. So now I have an eCore that describes something like a coffee machine. So this is the classes that make up a coffee machine, like a brewing unit, for example. And the other part it pulled into my workspace is a view model, which is the equivalent to a UI schema. In the Eclipse ecosystem, there's a really neat function here for a preview. So this is a preview of what the view model displays. It's a little bit more complex. And what you can do now on the view model is you can export that to JSON forms. And the exporter will ask you to browse a location for a JSON schema. So I will go to our React application. Without changing any of the code, I'll just override the schema. And then I will browse for the UI schema. And now it will ask me if I really want to override those two files. I've done that now. Go back into the application. Now I have an application that is rendering some coffee maker UI that lets me select some manufacturing process and whatnot. And even some more complicated controls with arrays of something. So it's really simple to convert those applications. And finally, of course, it is not only limited to desktop or to the web. You can, of course, also take the same approach to create mobile apps. That's something we are recently working on. And I can already show you an initial version of that. To get onto mobile phones, we use a framework that's called Ionic. And Ionic allows you to deploy web applications onto mobile phones. Maybe I should start with the deployment while I'm still talking, because it's not that fast. So hopefully this will spin up an emulator of an Android phone and then deploy an Ionic application onto that phone. The idea of Ionic is to, with an HTML-based application that runs locally, mimic the UI on a mobile phone, either an Android or an iOS phone, and basically they do that with styling. So this is a playground application that we have built, which has a form-based UIs to input some orders. And this is also based on a UI schema, on a JSON schema, and on JSON forms. And the only difference to what I've shown you in the browser is that we plug in a different renderer set. In this case, a renderer set that creates Ionic HTML to display the form. So, since I've promised to also talk about JSON Forms 2.0, so what specifically happened with JSON Forms 2.0? We improved the architecture quite considerably. We have changed it to a Redux-based architecture. What mainly changes for you as framework users is that the renderers got really, really simple, like the one we've seen. Because previously with JSON Forms 1.0, the renderer would also be responsible to pick up changes in either the data or the schema or the UI schema. This is now driven by the framework. So when your renderer needs to re-render, it's triggered by the framework. There's no need to register for change events or anything like that. So the renderers become really a simple one-shot renderer. And then we've added renderer sets, obviously, since we do that with React now. We have a material React renderer. We also have a vanilla React renderer. We are working on an Ionic renderer, and you have seen the initial results of that. This is going to be completed pretty soon, so within that year. We're also working on an Angular material renderer set, so that you can use Angular material design. This is supposed to be finished with the end of January 2019. And while we do that now quite frequently, we improved a lot of things like the architecture. So my estimate for the technologies that we've seen so far, it takes something between 20 and 50 days just to create an entirely new renderer set for a new technology. So that's fairly simple to do because you can reuse a lot of the existing stuff in the core. What's also new is we have added more stuff from the schema, from the JSON schema to support. So now we are more complete with regard to the JSON schema. If you're familiar with JSON schema, we can now handle any of and all of, and we can resolve references. And we have worked a lot on tree support as well. So we have a tree now, tree with detail component that allows you to render a tree with a detail that then is a form again. And we even have a tree editor component, which is a full tree-based editor, which is useful if you build modeling tools. And since we build modeling tools, we also have an integration of that tree editor into Thea. If you would like to know more about that, there's the JSON Forms webpage, and we Twitter about our updates there. There's the EMF Forms webpage. And on EclipseCon Europe, the next talk in this room, I will be talking about building web-based modeling tools with Thea. And for that, I will also use JSON Forms for the tree-based editors with this tree-based component I just talked about. And then after that, there is another talk that I would recommend that is also about Eclipse Thea that I find quite interesting. I don't know how much time, maybe 2 more minutes for questions. Otherwise, it would be great if you could evaluate the session. Is there any questions? None. Then thank you very much. I will be around if you have any questions, and I will be at the booth later if you can't catch me here. Thank you.